Okay, what we're going to look at now is what we call the difference of two squares. Now, hopefully some of you remember this from earlier in the year. Okay, now the difference of two squares was what we called one of the special situations with expanding brackets. Okay, so when we had a plus b, a minus b, and we expanded those brackets, with the shortcut, what we actually get is a squared minus b squared. Hopefully you all remember that. If you don't, please learn it, because it will make your life a lot easier in year 3 and definitely in year 4. A lot of people forget this one and it really helps them later. Okay, now we call this a difference of two squares because you have a squared and you have b squared. Those are two squares. And remember, when we talk about the difference, if I said to you, what's the difference between the temperature now and the temperature tomorrow, you would subtract it. Okay, so you would do today's temperature minus tomorrow's temperature. Okay, this is one square minus another one. So that's why we call it the difference of two squares. Now, what I've said to you is that what we're looking at now is still factorizing. Okay, so this was what we did earlier in the year. We went from the left over to the right. Okay, what we're going to do now is we're going to go back the other way. Okay, so I'm going to give you a difference of two squares and you need to put it into brackets. All right, now as an example, these are pretty easy, to be honest, guys. These are pretty nice. If I said to you x squared minus 16, okay, you have x squared, okay, and you have 16, so we have x squared minus, and 16 can be written as 4 squared. This is the same thing, isn't it? Okay, it's the same as x squared minus 4 squared. Now we have 1 square minus another square. Okay, and you could see back up the top here, a went here and here. Okay, and the second square, b, went here and here. Okay, we're just going to do the same thing. Okay, so this is equal to x plus 4, x minus 4. And that's it. All right, let's try another one. Okay, so if I said to you, we want to do 25 minus c squared. Okay, so that's the same as 5 squared minus c squared. And again, 5 is our first square and c is our second square. So we can turn this into 5 plus c, 5 minus c. And that's it. Okay? All right, if I give you, let's make one a little bit harder. So let's say a squared minus 7. Okay, now 7, that's not a square of something, is it? Okay, so we can't write that as something squared, except we actually can. Okay, we did this earlier. We did this in chapter 5 or 6. Okay, so we have a squared minus, now 7 is the same as the square root of 7 squared. Okay, so our first square here is going to be a. Our second square is going to be the square root of 7. Okay, so in this case we get a plus root 7, a minus root 7. Okay, and this is a difference of two squares still. Okay, even though the second term didn't look like a square. Okay, now sometimes you are going to see some things that make this a little bit difficult. Okay, one example of that is if we don't have necessarily a square at the beginning. So for example, if I said to you x to the power of 4 minus, let's say 4x squared. Okay, now here, this is a little bit harder, okay, because what you can see is actually we can already factorize something here. Okay, you can see straight away that x squared, both of these terms can be divided by x squared. So that means before we do anything, we need to take that x squared as a factor. Okay, so we have x squared. x4 divided by x squared is x squared. Okay, and 4x squared divided by x squared is just -4. Okay, and now we can see in our brackets that we have those two. Whoops, this one's not quite a square yet. Now we have in the brackets we have a difference of two squares. So we have x squared brackets x squared minus, and 4 can be written as 2 squared. Okay, so now we have a square here and we have a square here. So we're going to write this as x squared brackets x plus 2 x minus 2. Okay, and now we've done a difference of two squares. Now, the other important thing here is if we go back through all of these examples, you will see all of them were minus. Okay, all of these were minus. Okay, so all of them are minus. So what do we do if we have a plus? So what do we do if our question is to factorize, say, let's stick with x to make it easier, x squared plus 25. Now, many people think that if we have something like this, oh, that's easy. We can write this as x plus 5, x plus 5. Okay, so people think this is the answer. Okay, but what I want to do is I want to expand this and see what we get. All right, now, remember, this is a plus b squared, okay, where a is x and b is 5. Now, you hopefully remember that when you have an a plus b squared, you get a squared plus 2ab plus b squared. If you don't remember this, it's time to learn it. You're going to need it in year 3, you're going to need it in year 4. Okay, now, in this case, so we get a square of the first term. So let's look at our example. So we get the first term squared, so x squared plus 2 times a times b. Okay, so 2, multiply them together. X times 5 is 5x, and we times that by 2. So we get 10x plus b squared, which is 5 squared, or 25. Okay, now, whoops. Now, does this here look like this here? No, it doesn't. Okay, so this is not correct. This is not going to work. Okay, no. Well, we won't say no to this because this is important. All right, so this is not going to be our solution. All right, if you get x squared plus 25, this can't be factorized. Okay, so x squared plus 25 can't be factorized. Okay, so when we factorize a difference of two squares, it must be a difference. We must have that minus in there. Okay, so it must be with a minus. All right, that's it. Please have a go. But just as I said, remember that sometimes we must factorize something else out first. So sometimes we must first take a common factor out. Okay, good luck.